The ability to apply variable external forces to materials allow us to alter their surface properties at will, as well as find optimal catalytic activities and demonstrate new properties.
This technique allows us to apply strains and study their effect on electrocatalytic activities without needing to prepare multiple materials for each discrete degree of strain.
These methods can also be used to study a range of thin films and their electrochemical properties, such as electrochemical activity and corrosion.
For chemical and mechanical polishing of nickel-titanium substrates, first, cut a 0.05 mm thick piece of superelastic nickel-titanium into 1 by 5 cm strips, and sequentially polish the resulting samples with 320, 600, and 1200 grit sandpaper. Rinse the sample with ultra-pure water between each polishing. After the last rinse, polish the sample with 1 micron diamond, 0.3 micron diamond, and 0.05 micron alumina polish. After polishing, sonicate the samples with sequential 5-minute baths in ultra-pure water, isopropanol, ethanol, and ultra-pure water before drying the samples under nitrogen. To prepare 50 nanometer thick rutile titanium dioxide,